Alright, so आज का हमारा टॉपिक है atoms and molecules. Most of the stuff that we are going to cover in this short lecture, you would probably have seen earlier um, in your probably in your O-levels classes. लेकिन हम जल्दी से इसका review करेंगे and we'll introduce some new concepts also. So first, let's talk about what are atoms, right? So ये लफ्ज़ आपने बहुत सुना होगा and इसकी बहुत basic definition ये है कि atoms are the basic unit of matter. Okay. Back in the old days, पुराने टाइमों में atoms were thought to be the smallest unit of matter. Basically meaning that atoms को इससे ज़्यादा आप divide नहीं कर सकते, matter को atom से ज़्यादा आप divide नहीं कर सकते, and matter is the indivisible part. Atoms are the indivisible part of matter. Okay. लेकिन now scientists can divide atoms. We all know that atoms have other things in there, though it's not trivial to do that. Anyways, so three parts of atoms, or three things inside atoms that we most interested are as follows. So the first is atoms have protons, फिर atoms have neutrons, secondly, and the third important thing that we will be concerned with is that atoms have electrons. Okay. The symbols that we're going to use here for these three entities, for protons we'll use a p, small p, neutrons के लिए हम n use करेंगे और electrons के लिए we'll use e with a negative sign, and you'll see later on why we put a negative sign here. Anyways, so these three things are what we are concerned with in an atom. Okay, so when we talk about these three things, what about the masses of these? So what's the mass of a proton? Okay, so in kilograms, the mass of a proton is 1.672 times 10 to the negative 27 kilograms. So that's very, very, very small. 10 to the negative 27 power. Okay. So when people talk about a mass of a proton, they don't like to talk about in this really small number. So what they have done is they said, okay, let's define these relative masses. So they say कि अच्छा प्रोटॉन का मास हम बोल देते हैं कि 1 है, ठीक है. So these are called as relative mass. यानी कि किसी ने बोल दिया कि अच्छा भाई हम प्रोटॉन को मास 1 यूनिट दे दिया, ठीक है. Now protons और neutrons का mass equal है, so neutrons are also 1 unit in mass. Now electrons are very, very small in mass compared to protons and neutrons. So in fact, 1 proton is equal to the mass of 1836 electrons. Okay, mass terms. So electrons, they come out to be nearly 0, but if you want to be precise, it's 1 over 1836. Most of the time people will just say in relation to protons and neutrons, electrons are nearly 0 in mass. Next thing is the charge. The charge on these species. So neutrons, as the name suggests, are neutral. Protons are positive, as the name suggests, और electrons पे charge होता है वो है negative. ठीक है? So what about the magnitude of these charges? So the charge on 1 electron in terms of coulombs is 1.602 times 10 to the negative 19 coulombs. Okay, so again this is a very small quantity. So what people have said is that alright, so let's say कि जो charge है एक electron पे, we'll just say it's -1. Okay, so और electron और protons का जो charge है is equal. So it comes out that proton का भी charge 1 होना चाहिए in magnitude. Right? So that's the relative mass and charge of protons and neutrons. Now how are these things arranged inside an atom? So if you draw, you might have seen this picture earlier, the way you draw an atom is that you have this nucleus in the middle. This nucleus has your protons P and neutrons N in the nucleus. Okay? So neutrons are neutral, protons are positive, so nucleus is very positively charged. and then you have your electrons orbiting the nucleus, just like in our solar system, planets are orbiting the sun. So this analogy, we now know, scientists know, is wrong. This is not how the electrons move around in the atom. But for the time being, ये हमारे लिए काफ़ी है. We can take this image. Later on, we'll learn exactly how electrons are arranged around the nucleus. ठीक है? So again, in the nucleus, you have protons, neutrons, positively charged. Electrons, which are negatively charged, they orbit around the nucleus. ठीक है? So now let's see कि how are these elements, let's say, how are these things depicted in the periodic table? So we have here a periodic table जो कि आपको एग्जाम्स में मिलेगा, and let's take the example of, here we'll take the example of carbon. ठीक है? So carbon, so you see these numbers, ऊपर 12 लिखा है, नीचे 6 लिखा हुआ है, और कार्बन का सिंबल है C. ठीक है? So let's write this down here. So we are looking at the arrangement in periodic table. So we have carbon C, ऊपर इसके 12 लिखा है और नीचे यहाँ 6 लिखा है. Another things, another format you'll see, इसके कार्बन लिखा है, ये लेफ्ट पे ऊपर है ना, 12 यूँ लिखा होगा और 6 या नीचे लिखा होगा. कभी कभी सिर्फ 12 लिखा होता है, 6 नहीं लिखा होता है. Anyway, these are different ways to write carbon. So the question is, if I write carbon like this, 12C6, what's 12 and what's 6? ठीक है? So 12 is what's called the nucleon number, also known as the atomic mass, and it's represented by the letter A. Okay, and this is simply the sum of number of protons and number of neutrons. Right? So simply you sum the protons and neutrons, you get the nucleon number or the atomic mass number represented by an A. ये जो number 6 है, this is known as the atomic number. Okay, और इसको हम represent करते हैं by a C, and this is simply the number of electrons. Right? Now, atoms usually, so when you talk about atoms, usually we talk about a neutral species. ऐसी species जिस पे कोई charge नहीं है. So by that definition, so if we take a carbon atom, it's basically that it's neutral. So that means that your number of protons has to equal number of electrons. Okay. Again, this is because protons positively charged and electrons negatively charged. Atoms are usually neutral, right? If I talk about a carbon atom, it's a neutral species. So protons का number जो है और electron का number है, the number of these things have to be equal. Otherwise, अगर protons ज़्यादा है तो protons ज़्यादा है electrons से, then your atom would be positively charged. अगर electrons ज़्यादा हो गए तो negatively charged. So for to be neutral, protons and electrons have to be equal. And here I made a mistake here. In the atomic number, I should have said the atomic number is the number of protons. Right? Now, by this analogy, atomic number is also, since protons and electrons are equal in an atom, the atomic number is also the number of electrons. Okay? Simple. Now, in the periodic table, if you look over here, everything is arranged by the atomic number. So if you go from, let's say, left to right, you'll see the atomic number. Lithium has atomic number of 3, then beryllium is 4, boron is 5, carbon is 6, 7. So you see atomic numbers, they're increasing as you go left to right. And similarly, if you go bottom top to bottom, they are increasing 3, 11, 19, but your single increases that's left and right. As you go down the groups, the increase is higher. Okay, so things in the periodic table are arranged by the atomic number, right? And this atomic number is actually very important. It's basically the identity of the atom. So if I tell you something has an atomic number of 20, okay, that something has to be calcium, okay, because only calcium can have an atomic number of 20. The nucleon number, atomic mass number, can vary, and you'll see how it can vary. But if some species has an atomic number of 20, which number of protons is 20, it is calcium. Okay, you can say that confidently without any doubt. Now let's do some examples where we calculate number of protons, neutrons. We'll do a simple example. Alright, simple example. So first we'll do strontium, which has a nucleon number or atomic mass number of 84 and an atomic number 38. Okay, so we know that the nucleon number A is 84 here, and the atomic number Z is 38. So the number of protons that strontium has in its nucleus has to be equal to the atomic number, which is 38. Okay, and the number of protons, or let's say number of electrons first. Since strontium is a neutral species, then the number of electrons have to equal number of protons, so you just have 38. And what about number of neutrons? Well, that's just your atomic mass, or the nucleon number, minus the number of protons, or the proton number, which is C. Okay, so in that case it's just 84 minus 38, and that comes out to be 46 neutrons. Okay, another example, or I guess it's pretty simple and straightforward, right? So I won't do anything else, but you can pick any element, any atom from the periodic table and do a similar analysis. Let's talk about what are ions. Ions. Okay, so ions are charged species. Okay, these are just like atoms, but they have charge. So the way ion forms is basically, let's say you have a chlorine atom. Okay, now chlorine atom has let's see, so let's go to the periodic table, look at what's chlorine's atomic number. So chlorine is 17, atomic number of 17. Okay, alright, so chlorine with an atomic number of 17, which means the protons are 17, electrons are 17, so it's a neutral molecule. Okay, neutral atom. So what chlorine likes to do is it likes to gain an electron. So if it gains an electron, right, then what happens is the number of protons stays the same, but electrons now become 18. Okay, and electrons are negatively charged. Now you have one more electron than the protons, so then chlorine, Cl, becomes negatively charged. So you put this 1 minus on there. So now you say that you started with an atom, but when it's charged, it's called an ion. Okay, so you can gain electrons, becomes an ion, and in this case it's a negative ion. Okay, now other things can become positively charged. So let's say we have magnesium, whose atomic number is 12. What magnesium likes to do is that it likes to lose electrons, and actually it likes to lose 2 electrons. Later on you will know why some things like chlorine like to accept electrons, why some things like magnesium they want to lose the electrons. ठीक है, so magnesium ने यहाँ पे 2 electrons lose कर लिए. So starting out magnesium would have 12 protons क्योंकि उसका atomic number 12 है, और electrons have to be equal to number of protons, क्योंकि neutral है. But now it has lost 2 electrons, so इसका charge Well, first of all, let's write down the number of protons is the same, or जो electrons, now since it has lost 2 electrons from the starting quantity of 12, so it has only left with 10 electrons. Now you have an imbalance between protons and electrons. You have protons ज़्यादा हैं, electrons कम हैं. 2 protons ज़्यादा हैं, so the charge becomes 2 positive. So in this case, what you have created is a positive ion. Alright, so these are what you call ions. Okay, so clear with what are atoms, their proton numbers, atomic mass number, right? Pretty simple and straightforward. Next, we'll talk about another thing which is called isotopes. Okay, again आप लोगों ने शायद ये पहले पढ़ा हुआ होगा isotopes, probably in your metric or O-level classes. So we're going to talk about isotopes. Okay, so easiest way to explain isotopes is by an example. So let's talk about hydrogen. So hydrogen, if you go to the periodic table, it has the nucleon number of 1, this atomic mass of nucleon number of 1, और इसका जो atomic number है, that's 1 also. So this tells me that hydrogen has 1 proton, it has no neutrons, and it has 1 electron. Okay. Now scientists have found out that there's another type of hydrogen. Okay, और इस हाइड्रोजन का well, जो एटॉमिक नंबर है वो तो 1 है. ओके, क्योंकि वो 1 होना चाहिए, अदरवाइज वो हाइड्रोजन नहीं होगा, वो कुछ और होगा. सो एटॉमिक नंबर तो 1 है, बट उसका जो न्यूक्लियन नंबर है दैट्स 2. सो व्हेन दे डिड द एनालिसिस दे फाउंड कि अच्छा प्रोटॉन तो एक ही है, लेकिन अब न्यूट्रॉन्स एक और हो गया. पहले हाइड्रोजन में एक भी नहीं था, लेकिन इस हाइड्रोजन में एक और हो गया है. इलेक्ट्रॉन वही सेम है. और फिर उन्होंने एक और हाइड्रोजन उनको मिला जिसका अगेन प्रोटॉन नंबर तो सेम है, एटॉमिक नंबर सेम है, लेकिन न्यूक्लियन नंबर 3 है. तो इस वाले में एक्चुअली 2 न्यूट्रॉन निकले. ठीक है, अगेन जो एटॉमिक नंबर है इट हैज़ टू बी सेम, यू नो, अदरवाइज वो हाइड्रोजन ही नहीं होगा. इसकी वजह से प्रोटॉन्स आर ऑलवेज द सेम, लेकिन क्योंकि न्यूक्लियन नंबर्स आर डिफरेंट then your number of neutrons are different across the. So these species which have the same number of protons but different number of neutrons, which makes the atomic mass different, उनको हम बोलते हैं isotopes. ठीक है, और हाइड्रोजन के जो isotopes है उनके स्पेशल नेम्स है. सो द बेसिक हाइड्रोजन इज जस्ट हाइड्रोजन. एक्चुअली उसका भी अलग नाम है, इट्स नोन एज प्रोटियम. और फिर ड्यूट्रियम, and then we have tritium. Okay, so simple isotopes are, so if I write down the definition, isotopes are atoms of the same element. So same element means same atomic number, right? But with different nucleon number. Right? Simple and clear? Okay. So now the question is कि अच्छा मैं periodic table में जाता हूँ. ठीक है, सो मैं periodic table पे जाता हूँ और मैं देखता हूँ कि भाई, alright, so I see, so for example we talk about neon. अच्छा मैंने neon को देखा. So neon जो है I see that इसका न्यूक्लियन नंबर है 20.2 और प्रोटॉन नंबर द एटॉमिक नंबर इज 10. ठीक है, सो अब ये कौन सा, यानी कि नियॉन का ये कौन सा आइसोटोप है जो यहाँ पे रिप्रेजेंटेड है, राइट? सो लेट मी राइट दिस डाउन. ओके, सो मैंने नियॉन लिया, एंड आई सॉ दैट इसका जो न्यूक्लियन नंबर है वो 20.2 है, ठीक है। नाउ द क्वेश्चन इज कि फर्स्ट ऑफ ऑल कि डेसिमल कैसे हो गया, ठीक है, और अगर डेसिमल भी हो गया है तो ये कौन सा आइसोटोप है नियॉन का जो कि पीरियोडिक टेबल है, बिकॉज वी नो आइसोटोप्स आर प्रेजेंट आर यूजुअली अकर इन नेचर, सो पीरियोडिक टेबल पे कौन सा आइसोटोप दिया हुआ है। ओके, सो नियॉन का अगर आप कोई सैंपल लें, यू नो एक्चुअली मैं अगर आपको 10 किलो नियॉन दे दूँ, ठीक है, एक्चुअली नियॉन इज अ गैस, सो 10 किलो नियॉन would be hard to handle. But anyways, so if someone gives you some neon, what scientists found is that neon consists of 3 isotopes: neon 20, neon 21 और neon 22, ठीक है। और ये 3 isotopes they occur at a particular percentage in nature. So neon 20 जो है occurs 90.9%. Neon 21 is a very small amount, 0.3%. और neon 22 है जो वो है 8.8%, ठीक है। So these percents basically mean that अगर मैं आपको 10 किलो मैंने नियॉन दे दिया तो उसमें से तकरीबन 9 किलो जो है 9.1 किलो वुड बी नियॉन 20, 300 ग्राम तकरीबन नियॉन 21 होगा और तकरीबन 900 ग्राम नियॉन 22 होगा, ठीक है। These are the percentages. So basically what now we can do is we can find the weighted average. So the term they use here is the weighted average mass of neon. We can calculate this. This means कि on average अगर मैंने 1 किलो उठाया नियॉन का तो उसका वेट क्या होगा, ठीक है। सो इसको कैलकुलेट करने के लिए इट्स प्रीटी सिंपल, यू टेक इट्स परसेंट and you times it by the nucleon number. So you take the nucleon number here, times it by the percent it occurs in nature, ठीक है। फिर दूसरा वाला you take 21 times it by the nucleon number, times it by the percent, plus take the third nucleon 22 and times it by its percent occurrence, ठीक है। Now it's just your basic algebra. When you take out the percent signs, you have to divide by 100, right? So I'm taking out percents at all 3 places and dividing by 100, ठीक है। Now if you do this math, you'll find that the weighted average mass of neon isotopes is 20.2, and this is what you see in the periodic table. So periodic table gives you the weighted average of all the isotopes of a particular element that are found naturally, ठीक है। So in the case of neon, that average is 20.2, okay। That's why usually the atomic mass or the nucleon number is the number of protons and neutrons, or ये decimal नहीं हो सकता क्योंकि either you have 1 proton or you don't have any protons. But whenever you see a decimal like this, 20.2 for the nucleon number, it means कि it happens because you're taking an average of all the isotopes, ठीक है। Right. So now we're going to do a couple of definitions, ठीक है। So initially we said कि जो mass है, जैसे प्रोटॉन का मास हमने बोल दिया कि वो है 1 यूनिट, राइट। सो व्हेन यू गो एंड लुक एट द पीरियोडिक टेबल, आपने कार्बन देखा तो कार्बन का मास आपने बोला 12 है क्योंकि उसमें 6 प्रोटॉन्स और 6 न्यूट्रॉन्स है, राइट। बट वी नीड अ मोर स्टैंडर्ड डेफिनेशन. So scientists have come up with this definition for the relative atomic mass, alright? And this is pretty simple. They have said कि हम सब atoms का जो mass देखेंगे will look at the mass in relative to the mass of carbon, ठीक है. So क्योंकि कार्बन जो कि 12 है, ठीक है, इसके 6 प्रोटॉन्स हैं, 6 न्यूट्रॉन्स हैं, that's why you get a nucleon number of 12, right? So they say कि now we'll create this carbon 12 as a standard, और हर दूसरे एलिमेंट का जो मास है वो हम कंपेयर करेंगे कार्बन से, और फिर हम उसको मास देंगे जिसको हम कहेंगे द रिलेटिव एटॉमिक मास. सो इट्स नथिंग डिफरेंट देन व्हाट वी हैव सेड कि जब हमने प्रोटॉन को 1 यूनिट का मास दे दिया रिलेटिवली स्पीकिंग, क्योंकि बहुत छोटा होता है उसका मास, तो हमने बोला ये 1 यूनिट है. अब हमने प्रोटॉन को 1 यूनिट दे दिया तो कार्बन ऑटोमेटिकली बिकम्स 12, राइट. सो नाउ टू स्टैंडर्डाइज एवरीथिंग दे सेड कि अच्छा हम कार्बन 12 से एवरीथिंग हम उसको उससे कंपेयर करेंगे, ठीक है. So if you read the definition here, the relative atomic mass, which is also represented by, that's not a good color, अच्छा ये नजर आना चाहिए, AR, A subscript R, relative atomic mass is the weighted average mass, again so weighted average जो हमने अभी भी calculate किया, of naturally occurring atoms of an element. This means you take into account all the isotopes, सब isotopes का आपको account करते हैं, उसका weighted average है. So the relative atomic mass is the weighted average mass of naturally occurring atoms of an element on a scale where an atom of carbon 12 has a mass of exactly 12 units. Again, comparing it with carbon 12, ठीक है. उसका 12 यूनिट क्यों है? क्योंकि उसमें 6 प्रोटॉन और 6 न्यूट्रॉन है. हमने बोल दिया एक प्रोटॉन 1 यूनिट है, so you have 12 units, right? So as such now हर एटम को एक मास दे सकते हैं, राइट. और they call this relative atomic mass. It's just a definition. Mostly you won't use this ever again, but still you need to know the definition. Mathematically हम इसको express कर सकते हैं by this equation where you basically take the average mass of one atom of the element. This is against the weighted average जो हम isotopes के calculate करते हैं. You times it by 12 and divide by the mass of one atom of carbon 12. Again, this equation you will rarely use, but I just put it in there in case you come across it later on. Alright, इसी तरह से हम लोग define कर सकते हैं a few other quantities. So let's look at that. So the first quantity is relative isotopic mass. So it's similar to the relative atomic mass, but in this case you're talking about isotopes, not atoms. ठीक है. So in the example of neon we did, if we talk about neon 22 isotope, the isotope of neon whose nucleon number is 22, so in that case we just call that the relative isotopic mass. So let's say in this case R relative isotopic mass is just 22. Okay, again simple definition, nothing more. Now the next thing is more important, what we call the relative atomic mass, or not atomic, molecular mass. So जैसे relative atomic mass was for atoms, relative isotopic mass was for isotopes, this is for molecules. Okay, and this we need to know how to calculate this. Okay, and it's pretty simple. It's just, this is just the sum of the relative atomic masses of all atoms in a molecule. ठीक है. So let's see कि CH4 का relative molecular mass क्या है. And relative molecular mass is represented by Mr. So Mr for CH4 simply would be the relative atomic mass of carbon plus the relative atomic mass of hydrogen, but since we have 4 hydrogens we have to times this by 4. ठीक है. Now you can go to periodic table and you will know that the atomic mass of carbon is 12, right, and for hydrogen is 1. So this will give you a molecular mass, a relative molecular mass of 16 for CH4. Okay, simple. And later on we'll just use molecular mass instead of relative molecular mass. Just simpler to say that. ठीक है. Lastly, the last thing we need to do over here is the relative, bad writing, okay, last thing is relative formula mass. So formula mass is just for formula units. Instead of molecules, this is for formula units. Okay, so like we have magnesium hydroxide. Again, this is very simple. MR would be equal to the relative atomic mass of magnesium plus 2 times the relative atomic mass of oxygen plus 2 times the relative atomic mass of hydrogen, right? And these again can be, we can get from the periodic table. So magnesium is, I don't remember that, so let's find it from the periodic table. Here's magnesium. Magnesium is 24.3, right? So magnesium is 24.3. Oxygen, I remember, is 16. So 2 times 16. Hydrogen again is just 1. And if you do the math here, this will come out to be 58.3 for magnesium hydroxide. Right? So pretty simple. The relative formula mass or relative molecular mass, you just go to the periodic table, sum up the relative atomic masses of your of the atoms that make the molecule or the formula unit, and you have your relative formula mass or the relative molecular mass. Right. The last thing that we need to cover here is mass spectroscopy. All right. Oops. Where are we? 1 second. Let me get this in place. Okay. Now it's in this place. Yes. So last thing that we need to cover here is mass spectrometry. Okay. So earlier we saw that neon has 3 isotopes, and I told you that the 3 isotopes of neon, so let's say neon 20, neon 21 and neon 22, they occur at a frequency of 90.9%, 0.3% and 8.8%, right? Now the question is कि ये percentages आई कहाँ से, ठीक है? So इस percentage को calculate करने के लिए the method that's used is called mass spectrometry, ठीक है? इसमें हम क्या करते हैं, basically आप जैसे आप नियॉन का देखें, राइट? आपको नियॉन के आइसोटोप्स की फ्रीक्वेंसी मालूम करनी है, राइट? Get what frequency or what relative, the term they use is relative abundance. At what relative abundance do these neon isotopes occur in nature? So आप ये neon का sample लेते हैं, you put it in this machine and this machine gives you a readout of the relative abundance of neon isotopes, ठीक है? The way the instrument works is pretty simple. You put your sample here in this instrument and it's vaporized. Vaporized, you know, you just convert it to gas. Neon वैसे gas होती है, but in other cases if it's solid you have to vaporize it. And then a heated element produces high energy electrons. You do that because you want to ionize your sample. Ionize means again you want to give it a charge, okay? क्योंकि जो separation होती है, basically the way it separates the isotopes is by charge. So you want to ionize these things, and once it ionizes, what happens is that these are charged and then you have a magnetic field. So based on their masses, these things will get deflected. Let me pick a better color. This is a darker color. So what will happen is that some of the isotope will take this longer route and some will take this shorter route. Okay? And then you have a recorder here, a computer here, which records how fast these things are hitting your detector. Okay? So the things that take the longer route, they have to be heavier, right? So these are the heavier particles. Why they take? Well, they are longer, they are heavier, so they don't get deflected that much by the magnetic field. लेकिन जो lighter particles हैं, these ones, क्योंकि वो बहुत हल्के हैं, they get really deflected by the magnetic field. So their path, जो इनका route है, वो बहुत deflect हो जाता है. ठीक है. फिर आपका ये डिटेक्टर आपको देखता है, यानी कि ये डिटेक्ट करता है ये इन सबको, and it gives out a readout which is known as the mass spectrum. ठीक है. Mass spectrum basically tells you कि कौन कौन से आइसोटोप प्रेजेंट है. सो ये है मास स्पेक्ट्रम ब्लड का, एंड व्हाट इट टेल्स यू ऑन द एक्स एक्सिस इट हैज़ दिस mass to charge ratio. ठीक है. यूजुअली यहाँ पे चार्ज, what you will be dealing is the charge is just 1. So when you get a mass to charge ratio of 206, basically it's the isotope of lead जिसका mass है 206. So here you have 4 isotopes of lead. 204 वाला है, 206, 207, 208. So this is given here in a tabular form here too. You have the isotopic masses of 204 से लेके 208 तक. ठीक है. और फिर the other thing that you have in the spectrum is basically the frequency. कि इस sample में कितना isotopes हैं, कितना isotopes हैं, उनकी relative abundance क्या है, और उनको अगर आप tabular form में लिखें तो you get these percentages, right? So this is how basically you generate your relative abundance, this type of data which we used earlier to find the weighted average mass. Just 1 second. All right. So with that, this was the last thing we had to cover today in this video. We talked about atoms, ions, relative atomic masses, how to calculate the weighted average of isotopes, and lastly, mass spectrometry. Right? Hope you had a good time. I'll see you again later. Bye.